Isn't it funny how some projects can appear to be headed in one direction, and then all of a sudden, for no reason whatsoever, turn into something else? Yeah, I hate it when that happens. That was meant to be rhetorical, but you obviously missed the last few episodes, huh? 6 years ago, we bought a GT6 with a bit more rust than we thought. Well, quite a bit more rust than we thought. Okay, it was a ridiculous amount of rust, and the car was trying to return to the earth, which it didn't deserve, so our mechanical sympathy and a tendency to like complicating our lives led us to fix it. It's taken us 4 years to get the body shell restored to the point that it's actually metal again. And by metal, I mean steel, not the aluminum and Bondo that had been slapped on haphazardly by a previous owner. The last couple of years have focused on the Restomod side of the build, which was the intent from the beginning, albeit perhaps not quite to the extent it's turned into. We're still getting you caught up, but as you might be able to tell, we've still got lots left to do. The last few episodes have explained how after months of research and planning, we elected to take our British car, styled by an Italian, and completely redesign the drivetrain with, so far, American parts. All in our 10 by 22 foot garage here in Canada. We've already gone over the new engine, transmission, and differential we'll be using, none of which are as straightforward as they may seem. So, if you want to know more, we highly suggest checking out the last few videos when you're done here. Last time we got a large portion of our new custom chassis built, and we ended off by mentioning the differential will get mounted next, so let's get on with that. This architecture here is called the batwing, and it provides the two main mounting locations. It's cast aluminum like the rest of the diff body, but is far too wide for our car, which means we need to do some thinking. I'm thinking. He's got nothing. Wait, he's got something. I got it. What if we cut off the batwing and we build a steel structure that bolts on instead? No. What? You'd have to remove more casting than you think, and I don't want to compromise on strength just to make it work. Oh. Anyone who knows about the Corvette Dana 36 will tell you that they have their, shall we say, limits. And when they do let go, it's generally pretty spectacular. Nonetheless, our car is light, will have relatively small street tires, and if we can avoid clutch dumps on the drag strip, we should be fine. As a contingency plan, it's not impossible to upgrade to a Dana 44 later, just expensive. Okay, but the batwing? Right. Well, what if we just trim it down and weld it back up again? Well, if you want to take the obvious route. We couldn't think of a reason not to, so we did some measuring and got to work. We promptly cut off one of the mounts to see how close to our desired width we could get with relative ease. Conveniently, with one support removed and the mount slid inwards, it should be spot on, and we elected to leave the sections here intact as they will provide more area to weld and should keep things nice and strong. Before they get welded though, they will need the rubber bushings removed, as things are going to get pretty toasty. A drill helps to get rid of some rubber to work the bushing out, and a hammer and chisel can gently persuade the aluminum sleeve out with some patience. Did I say patience? I meant agony. A bit more trimming and tidying up gets it fitting like this, and we're quite pleased, so let's duplicate it. Easy breezy peasy. To finish it off, we rigged up a steel support bracket to keep everything spaced perfectly while it's out for welding. Out for welding? Yeah, out. Okay, look, the whole oot thing is completely overplayed. No, I mean, why not weld it yourself? Oh. Well, that's pretty simple, actually. We physically had no way to do it. We had no TIG, our Lincoln would have needed a spool gun and argon, and it just seemed best to pay someone else who was already set up and, perhaps more importantly, knew what they were doing. Jumping into aluminum welding is a task in itself, let alone cast aluminum. Now, as I mentioned, this all happened a while ago, and somehow, incredibly, I managed to lose track of a bunch of footage for the next few steps. This frustrates me beyond belief, but it's all in the past, and short of a DeLorean, we'll have to go with what we've got. Here's a terrible shot of the diff after we got it back from TIG welding, and after we spent some time with assorted sanding wheels to clean it up and blend the parts together. With it mocked up in place again, you can see the difference the narrowing has made, and you can also hopefully imagine how some mounts off the sides of the frame rails will work out. Before we can solidify the mounting though, we need to nail down a couple more variables. We've known all along that the Corvette axles and control arms will need to be made shorter, but without our new wheels and tires, the exact width is still unknown. The factory wheels on a GT6 were 13 by 5.5s. Yeah, 13s. That's 3 inches bigger than a Mini. 3! That's over 2 inches. That's almost 4 inches. However, our Corvette disc brakes back here are 11.3 inches plus the caliper, so they're definitely going to need a larger wheel than that. But we need to stay as small as we can, as we like some sidewall on our tires. 14s might just clear out back, but definitely will not work with our configuration we're planning up front, so 15s it shall be. That was an easy choice, but width is a bit more complicated as there are a few extra factors that come into play. Firstly, there's available room in the wheel well, and secondly, there's how far out we want the wheel to sit in relation to the fender flare. Thirdly, there's offset. Fourthly, there's the fitment around the brake and hub. And lastly, there's availability of tires. Quite. Without turning this into an entire video on its own, we decided that a 7 or maybe 8-inch wide wheel could fit, and that offset is somewhat variable, as we still need to set the suspension track width in the first place. As cars continue to get bigger all the time, tire selection is getting somewhat limited in the 15-inch wheel size. What we found to be the best bang for our buck were a set of Falcon Azenas RT615K Plus in the 205/50 size. And as you can tell, we're still gaining quite a bit of meat here over what our little Triumph used to run. You might think they're a bit narrow for the power we'll be putting out, but we don't want the car looking like a drag racer when it's done, and this size should suit the proportions nicely. They'll also function as the weakest link, burning rubber rather than grenading a differential or transmission, which is a real nice feature. Okay, so you've got your tires, you've got your wheel dimensions, now we can mount the diff. Patience, Quincy. We just need to find some wheels we like first. Now, we recognize that wheel choice is an extremely personal decision, and we've been through scads of options to find the right ones for us. Some are way too expensive, and others don't suit the style we're after. We narrowed it down to a set of silver Rotogrid concaves in a +20 offset. Although we've never seen these on a GT6 before, we have found plenty of Datsun 240Zs running them, and they look great. They're a nice balance of modern but not too modern, and the dished offset suits the car very well. With the tires mounted and road force balanced, we've got exactly the look we were shooting for, with a nice chunky sidewall and a squared off look. Our wheels use the super common 5 on 114.3 bolt pattern, so they should fit right up to our Corvette hubs. GM enthusiasts are probably having a good chuckle right now. Short story for the rest of us is I screwed up. I was sure that the Vette hubs were this pattern, but they're not. You see, GM in their infinite wisdom decided to use their own 5x120 bolt pattern, which is close enough not to notice the difference until it's too late. Time to make lemonade from some lemons, I think. The components we're considering up front use the correct bolt pattern, so all we really need to do is convert the Corvette hubs to match. We considered re-drilling them, but with these holes already present, there isn't enough material left to be safe. Welding up the holes is impossible because the hubs are a sealed unit, so our only real option is to replace them. I came across a document from Timken outlining all their different bearing hub assemblies by specs, and our solution came as a set of front wheel bearings for an early 2000s Jeep. We now have a bell housing and wheel bearings from Jeeps. It's a crazy old world indeed. Amazingly, these bearings share the same axle spline, the same 3-bolt pattern for hub attachment, and the spacing here is nearly identical. We needed a small amount of machining to reduce the diameters here, here, and here, and a custom spacer to take up a difference in length here. But we're talking about minor changes, and with some schematics given to our very kind friend with a machine shop, we're golden. It's actually all for the best in the end, as the old wheel bearings were due to be replaced anyways, and now we have the exact bolt pattern and thread pitch we'll be using up front, so it's perfect. We drilled 5 new holes in our discs for the updated pattern, and it can all go back together. Now our wheels fit beautifully, and best of all, it's shiny. Look at that, like silk. A final step was to take the cutting wheel to the uprights. These are where the sway bar and transverse leaf spring bolted up on the Corvette. But as we're not using either of those, and the mounts are killing what precious room we have to work with, they must be terminated. Cool. So now we can mount the differential? Yes, now we can mount the differential. The mounts consist of some 3x3s with one side lopped off. They'll get beefed up later, and everything is just tacked together for now, as we're still making sure it's in the correct spot. The front of the diff needs attaching as well, and the original torque beam isn't on the agenda. A custom bracket, yes, a bracket, has been fabricated to house a rubber bushing that would normally have resided in the GT6 leaf spring eyes. It ties into the diff through the factory mounting location with a pair of massive bolts. These shims have been engineered into the design to allow the diff angle to be adjusted slightly, as later on it will need to be aligned with the engine and transmission. A sturdy 2x3 and another bracket are fabbed up to receive the other side of the rubber mount, and it can get tacked into place. With all mounts now present, we can finally bolt up the Corvette axle and lower control arm to see how things are sitting. Yes. Bit wide, I'd say. Maybe some fender flares. Hey, you said back in episode 9 I won't be any wider. Good memory. Just checking. No, it won't stay like that. But it's interesting to see just how much wider an 85 Corvette is. Before making any permanent alterations, we took the time to create a mock axle shaft and lower control arm out of some scrap box tubing so we can set it up exactly how we want. This was the better part of 6 inches narrower than the factory Corvette parts, and it has pulled the wheel in far enough that it now clears the fender lip. Just. We might end up rolling and trimming the lip a tiny bit to help with clearance, but we're darn close. There's no real limit to maximum droop right now, but we're aiming for about 4 to 5 inches of total travel, and although that's not much, it's better than nothing. You might be able to tell that there isn't tons of camber change through this small range of motion, which is good, but there is just enough that it helps the tire pull in on the way up for clearance. Almost like this was planned months ago. Happy with the width, we sent our axles off to be cut and re-welded. This is the real beauty of using the C4 Corvette suspension. With any setup using CV axles, we'd have to order custom-made spline shafts. But since these are normal prop shafts, just really tiny ones, they can be narrowed up easily. It's a beautiful thing, and while not exactly cheap, it still saved a good chunk of change. While the axles were being permanently resized, we took a little tangent to remove the frame again and do some more welding. The diff mounts are now far less likely to be knocked off, and the gussets down the sides, which we only tacked on last time, have now been fully welded too. The 2x3 for the front diff mount has been fused in place, and with that, we took another side step again. Making things shiny. I'm a sucker for making things shiny, and when you've got a bunch of nice aluminum parts, why not take a second to sand them smooth and polish them up? I mean, honestly, which would you rather have under your car? With it bolted back up, we reinstalled our lower control arm template to make sure that everything is still exactly where it needs to be. And it isn't, so a few cuts and welds bring things back to our goal. This is precisely why you have to check and check again. Everyone always says to. It sounds like a waste of time, but when you don't, that's when you'll regret it. It's looking very good, just how we'd hoped. We love the wider stance and will be sticking close to 0 camber on all 4 corners, which looks a heck of a lot better than the ridiculous positive camber we've gotten used to seeing on our car. We can now test the components on the other side to ensure they fit the same, which, I mean, they should, or we've got bigger problems, but thankfully all is well. So everything's clearing, and it looks the way we want. Let's build the real lower control arms. Rather than listen to me babble on and freestyle in this clip, what we're doing here is using a jig. Well, a negative jig thing, actually. Yep, it's taken us 13 episodes, but we finally did it. I mean, I know it's not the most complicated negative jig thing in the world, but it just feels good being able to say we've made one, as if it's a fabricator's badge of honor or something. Either that, or we're slowly catching whatever disease Nick Blackhurst has. We're using 2 bits of tubing set square to the horizontal box. And these sleeves are the beginnings of the control arms, which slide down over the tubes to get located perfectly. A larger piece of tubing will then get fish-mouthed and welded in place to tie the sides together. We bought a whole new set of polyurethane bushings for the Corvette rear end, and we'll need to match the ID of the tubing to the bushing. As we don't have a lathe and want an in-house solution, we decided to run a piece of tubing inside a piece of tubing. The outer one is a heavy wall for strength, and the inner one is the perfect size for the bushing. The arms will be welded up without the inner sleeves first, and a series of plug weld holes will secure them together afterwards. The resulting piece turned out like this, and you can see just how much shorter than the old one it is. We got the sleeves welded in and spent some more time smoothing the transitions to make them look a bit more like a cast part. When it's all done, they'll be painted silver in an effort to make them blend in with the rest of the aluminum parts. They're finished in some rust converter right now, and with the bushings installed, you can see how the jig worked perfectly as they're exactly the same length and angles. That really gets us off to a good start with the rear suspension. We still need to figure out the trailing arms, but that is a task for next time, so let's end this off right there. Thanks so much for watching. If you'd like to see our future videos a day early, plus other benefits, please check us out on Patreon. Thanks very much to our awesome loyal followers who already support us that way. If you're not yet, make sure to subscribe and hit the bell icon so you won't miss anything, and please share this series with some friends as it would really help us out. We'll see you next time.